Hello everyone, and today we're going to take a look at some multiple choice questions from the Cambridge Igcse physics section. Now, these questions are just to give you guys an idea of what you'll face in the multiple choice section of the paper. Let's start with question number 15. It says, what does the area under the speed time graph represent? Now, the area under a speed time graph is simply, so if you can imagine this speed time. If you have a speed time graph, the area below this graph would show you the distance traveled, so the answer is D. Let's move on to the next question. It says, a car travels 100 kilometers, the journey takes 2 hours. The highest speed of the car is 80 kilometers per hour, while the lowest is 40 kilometers per hour. What is the average speed of the journey? Now, when facing these type of questions, you need to understand that if you want to calculate the average speed, the formula is simply going to be the distance traveled divided by the time taken, so d over t. Now in this scenario, the distance is 100 kilometers, the time taken is 2 hours. 100 divided by 2, that's 50 kilometers. As you can see, this is hours and kilometers being divided by hours, so kilometers per hours. The answer is indeed B. Now these two parts, 80 kilometers and 40 kilometers, are just distractors and unnecessary information. Moving on. Which distance time graph represents the motion of an object moving at constant speed? Now, when we're talking about distance time graphs, you need to understand that if you have a graph, like a curving graph, like the one that is in A and B, then if the graph is coming down from left to right, that's called deceleration, which means that it's basically slowing down, and in B, it's speeding up. In D, the graph is actually at a straight angle, and it's a straight line at an angle, and you can say that this graph actually shows you the speed of a car or an object moving at constant speed. So the answer is D. What about C? Well, whenever you see a straight horizontal line in a distance time graph, that means that the object is actually not moving. So the speed is 0. So the object is, in other words, stationary. Let's take a look at number 18 now. It says the graph shows how the speed of a car changes with time. Now, notice that in the first question that we did, we said the area below a speed time graph shows us the distance. So you can say that over here, the distance is simply going to be the area below this graph. And since this is a triangle, we know that the area of a triangle is simply equal to base times height divided by 2. Here the base is simply going to be the 24 multiplied by the height, which is 14, divided by 2. Now notice that the answers are given. So it says which calculation gives the distance. So you can obviously choose C, as that represents our calculation. Moving on to the next one. Now here are some questions that these are basically going into questions that are in the paper 2 of the exam. So you can imagine what you'll face in the exam by looking at this. We're going to do that in another video, as for now we're focusing on some multiple choice questions. Again, here we have a diagram, very simple thing. It says what is represented by the shaded area under the graph? Well, we know that this is a speed time graph, so simply distance. As you can see, these type of questions have been very prevalent in the exams that came before. And another question about the graphing, but before we do that, let's take a look at this one. It says a tunnel has a length of 50 kilometers. A car takes 20 minutes to travel between the two ends of the tunnel. What is the average speed of the car? Okay, so the length of the tunnel is 50 kilometers. That's obviously the distance. The time taken is given in minutes, 20 minutes. Now, if you want to go from minutes to hours, you'd have to understand that you can just multiply this by a fraction, which can get rid of the minute part. So you can multiply this by, say, 1 hour is simply 60 minutes. The minutes cancel each other out, and you get 20 over 60. So 2 over 6, which is literally 1 over 3. Thus, in order to calculate the average speed, you just have to divide the distance by time. So 50 over 1 over 3. Now, if you do far, far, near, near on this one, basically simple math, or you can just put it in the calculator, 50 is basically being divided by 1, and now you got 1 over 3 on the bottom. So far, far, near, near, that gives you 150 kilometers per hour. The answer is C. Moving on to the next question, it says the diagram shows the speed time graph for a train as it travels along a track. For which part is the train's speed changing at the greatest rate? Now, in a speed time graph, the slope at wherever the graph is, the place or the part which has the highest slope would have the highest speed. PQ obviously has a horizontal slope, so that's not the one. Q to R seems to be good for now, but R to S is also pretty fascinating because it looks like it has the highest slope, which basically means it has the highest gradient, or in a mathematical term, the highest rise over run. So in this one, the answer is actually R to S, despite the fact that it's a negative slope as the line is coming down. A small steel ball is dropped from a low balcony. Ignoring air resistance, which statement describes its motion? Now, this is a beautiful question because it's actually about free-falling objects. Now, we know that whenever objects are free-falling, they have one force acting that they have a couple of forces, actually. The first force obviously being the force of gravity pulling this down. That's the weight. And the other force, which is opposing this movement and upwards, that's the air resistance, the friction between the object and the air that is flowing through. It says, ignoring air resistance, however, which statement describes this motion? It falls with constant acceleration. Now, we know that the acceleration on Earth is the one that this ball will be dropping with, is simply going to be mass times gravity. Now, the acceleration on Earth is about 9.8 newtons per kilogram, will be rounded up to 10 newtons per kilogram, which is constant. So we're going to keep that choice for now. It falls with constant speed. That's obviously wrong because as it's falling down, the ball is going to have an increase in its speed. So that's definitely wrong. Its speed is not going to be decreasing. We have all tested it out. You can even test it right now. You can throw something out of your balcony and you will see that its speed is going to increase. So that's not correct. Increasing acceleration is definitely wrong because, well, we know that gravity is constant on Earth, which meaning that the acceleration by which this ball will be falling is constant. That leaves us with choice A, which is indeed the correct answer. Thank you for watching and stay tuned.